Page 31, number 153. Find the surface area of the cylinder in terms of A and B. So we're looking for surface area for the cylinder, but we're not going to have numbers plugged in for radius and for height. We're going to have A and B. So you're not expected to actually solve for A and B. You're just going to use them in your equation. So surface area formula equals 2 pi RH plus 2 pi r squared. Now, where does A and B fit? Well, your radius and your height are A and B. So everywhere that it appears R and H, you're going to have either A or B plugged in. Now let's take a look at which one is which. So A is connecting the circle in the front to the circle in the back. So that's your height. A connects the circle in the front and the circle in the back. So that's your height. So let's go ahead and write that down. Your height is A. Our radius is B. You'll notice it starts at the center of the circle to one end of that radius. Okay, so we're going to write down that our radius is equal to B. Now we're going to plug all of this in to our equation. So remember, we shouldn't have R, we shouldn't have H, and we shouldn't have R. We should use A and B instead. So our final answer for this question, surface area equals 2 pi, the radius is B, height is A, plus 2 pi, your radius is B, squared. So our answer is here. Surface area using A and B instead of radius and height. Let's move on. Number 154. Go ahead and read it and then come back. Okay, so let's come back and now annotate this question. At a local campground, the Girl Scouts are getting ready for their first overnight trip. Now that doesn't mean anything to us. That doesn't help us with any of the math. So far, the Girl Scouts have set up 9 tents for a rectangular portion of the campground pictured below. So now if we look at this visual, this here is a rectangle. It's 15 feet by 12 feet. And there are 9 tents inside. If the density of tents per, which means divide, tents divided by square feet is kept the same for the entire campground, approximately how many more tents can the Girl Scouts set up? Round to the nearest tent. So we're looking for the number of tents, the population of tents that's going to fill in this whole other section. That's going to be our goal. Now, when they talk about keeping density the same for 2 different sections, the way that I like to do these problems is proportions. So one more time. When they're talking about densities being the same for 2 different sections, in this example, we're talking about this trapezoid section on the left and then the rectangular section on the right. Those are 2 different sections of the campground. If density is kept the same, I'm using proportions. Now let's talk about why. So for density, let's say this is of the trapezoid shape on the left. You want it to have the same density as the rectangular portion on the right. Now you need to know, how do you find density? Well, density has its own density triangle, even when we're talking about population density. The population density triangle looks like this. Population density, P for population, A for area of the land. So what they're asking is they're asking to keep the densities the same. In other words, density, if we cross out the D, is population over area. So they want population over area to be equal for the trapezoid on the left to the population over area for the rectangle on the right. I like proportions. They're my friend. I always use proportions when I'm kind of confused. So in this case, when they're talking about two different locations with two different population densities, then I'm going to use proportions so that I can keep those population densities the same and consistent. Okay, so let's talk a little bit. Now I'm going to keep the trapezoid stuff on the left. Now I'm looking for the number of tenths that are going to go into the trapezoid on the left. So my population is going to be my variable. It's my x. I have no idea what the number of tenths are. Over the area of this trapezoid. Well, you know what? I'm going to have to figure out the area of that trapezoid because I can only have a variable in one place in this proportion. So let's go ahead and figure out the area of the trapezoid. Area of a trapezoid formula looks like this. Height times base 1 plus base 2 all over 2. So let's take a look at our trapezoid. Our height would be this entire vertical distance. So I have 10 for this piece, and then this piece here is 12. Same as that height on the right part of the rectangle. So in total, 10 plus 12 is a height of 22 feet. For that entire height, 22 feet. So I'm going to start plugging in. I have for area 22 parentheses. One of my bases is at the top. It's 8 plus base 2. Base 2 is right here. They don't give it to me, but they do tell me that 32 feet is the entire width of this shape. Since I've already used up 15 feet for the rectangle right here, I'm going to subtract 15 from 32. So again, I've used up 15 feet right here. So I'm going to subtract 32 minus 15. I'm left with 17 feet for this bottom base. Okay, so that's 17 feet. I'm going to plug in 17 feet all over 2. So in your calculator, you're going to start by adding 8 plus 17 first. So in the calculator, I only have 17 plus 8 equals. So that 25, we're going to multiply it by the height of 22 equals, and then divide by 2 equals. Okay, so my area for the trapezoid is exactly 275 square feet. Why did I need that? Well, area is the denominator when you're doing population density. So I'm going to plug in 275 feet squared. And remember, the x stands for the number of tenths that we have. And in this case, that's what we're looking for our trapezoid section. Now, we're going to set this equal to the population density for the right side of this campground, which is the rectangle. Now, the population of tenths in this rectangle, they told us is 9. So we have 9 tenths over the area of that rectangle. Well, area for any rectangle is length times width. So in this case, we're going to do 15 times 12 in the calculator. 15 times 12. We get 180 for our area. 180 square feet. Feet squared. Okay, so plug in 180 feet squared. And now notice how we match things up. The number of tenths we kept as our numerators. The areas of the two different sections was our denominator, and we just kept it consistent. Now what we're going to do is we're going to cross multiply. So cross multiplying, we're going to do number of tenths x times 180, which gets us 180x equals. Now we're going to do the 275 times the 9. So in the calculator, 275 times 9. We have 2,475. Last step, to get x by itself, we divide by 180. So divided by 180 equals 13.75. Okay, so rounded to the nearest tenth, because we're not going to have a fraction of a tenth. Rounded to the nearest tenth, well, 14 is the nearest tenth, because that's what we're looking for, a whole number. So 3 is going to round up to 4. So 14/10 approximately can fit into the rest of this campground. The rest, that 14/10 is going to be a little bit of a tighter fit than the rest, but if we're rounding to the nearest tenth, we can get 14 in there. Okay, so the big takeaway from this problem, when we're talking about population density and we have two different sections that we're talking about, we're going to make sure that we keep them consistent by setting up a proportion. Population over area. Population over area. Okay, let's keep moving. Number 155. Which equation would solve for x? Okay, so I look at this figure and it's a right triangle and I have an angle measure. So I'm thinking trig. And looking at all my choices, we have sine, cosine, tangent. So we're using trig. Now, I'm going to take a look at my diagram. Notice that I have 70 degrees as a reference angle. And starting from there, I'm going to label opposite, adjacent, and hypotenuse. Opposite, adjacent, and the hypotenuse is always across from your right angle. Okay, so if I'm trying to solve for x, I'm not going to use the opposite because I don't have anything for O and I'm not solving for it. I'm solving for x. So you need to think about which trig function uses a and h. So ka, toa, ka, which means you want to do cosine of 70 equals the adjacent divided by the hypotenuse. So my adjacent of x over my hypotenuse of 14. That will get me x right away. Let's take a look at our choices. The first one says sine of 70. Okay, well, I don't want to use sine, but it is setting it up correctly, x over 14, but it should say cosine instead. Choice B, cosine of 70, okay, that's what we want, equals 14 over x. Well, that's the hypotenuse over the adjacent. That's not what we want, so it's not choice B. Choice C, we have 20 and 20. Well, that's not your 70 degrees. Well, you know what? It's not choice A, it's not choice B. Well, where does this 20 come from? The 20 is actually the other angle. Because remember, we have, and I'm going to erase a bunch of this stuff. Okay? We have these two angles that should be complementary. Because we've already used up 90 degrees for our right angle. So we have 90 left over for the 70 degrees and the angle on the right. So when we do 90 minus 70, we're left with 20 degrees for your angle on the right. Let's see if we use the 20 degrees as a reference angle instead of the 70, if it'll give us either choice C or choice D. Okay, so now using the 20 degrees, I'm going to label in opposite, which is now my x value, my adjacent, and my hypotenuse remains as my 14. The hypotenuse never changes depending on your reference angle. It'll always be across from the right angle. Okay, so looking at what I have now, again, adjacent is not going to help me. So I want the trig function that uses O and H. So, ka, toa. So, O and H works with so, which is the sine function. So now if we do sine of 20, remember we're using 20 now, not the 70, equals opposite x over your hypotenuse of 14. Let's see if that ends up being one of our choices. So C says tan. Well, nope, we're not using opposite and adjacent. It's not tan. And D says sine of 20 equals x over 14. Perfect. That's what we want. So in this question, even though they gave us the 70 degrees and I could find x using my cosine function here, that wasn't one of the choices. So I had to look at the other angle, the 20 degrees, and see if one of the choices used the 20 correctly. And it did. It was choice D. So you have to know that you could use either the 70 or the 20 to solve for x. But you have to make sure the trig function is set up correctly. All right, let's keep moving. 156. Find the length of the diagonal in the rectangle to the nearest hundredth. Okay, so our ask is to find the length of the diagonal. So my ask is here. We want this red diagonal. That's what we need to get. In fact, we can call it x. What we have is a rectangle. Now, rectangle properties are that all your angles are right angles in the corner and the opposite sides are congruent. So this 84 feet up top is going to become the 84 feet at the bottom as well. Now, let's take a look at just one of these triangles that is formed. So if I take a look at just, let's say, this bottom one, for example, you'll notice that that is a right triangle. And with right triangles, we try to use either trig or Pythagorean theorem if we're trying to solve for a missing side. Now, since I only have one side length, I don't have two for my blue right triangle, I can't use Pythagorean theorem. I have to use trig. And notice I even have a 57-degree angle here, so that's perfect. I can go ahead and use trig. Now, labeling some things in, I'm going to start by labeling 84 feet as my opposite. My adjacent is the height of this rectangle, and the hypotenuse is the diagonal that we want to solve for. So since I don't have any value for the adjacent and I'm not trying to find it or solve it, I'm going to cross it off. Instead, I'm looking for the trig function that uses O and H, which is SO, sine function, SO. So with our sine function, I'm going to go ahead and set it up. Sine of 57 equals the opposite side, which is 84, over x. Now, when your variable's on the bottom in a trig function, you're going to have it switch with the trig function. So the x, or whatever variable you have as the denominator, switches with your trig function. So it looks like this. X equals 84 over sine of 57. Be careful with this calculator work. It's very important that you type it in correctly. Let's take a look. We're going to do 84 divided by. Once you've hit the division symbol, you're going to type in 57 first, then sine, then equals. So far I've done 84 divided by 57 sine, and it shows you what the sine of 57 is. Now you hit equals so that the division can actually happen. And then that's your answer. X equals 100 point, and now it says to the nearest hundredth, so 100.16 feet. That's the length of my diagonal. 100.16. One other thing I want to show you, just going to erase a bit here. If instead of using the 57 degrees, if I wanted to use this angle up here, because I have the 84 feet at the top, I can. That angle at the top, I'm going to do 90 minus 57 to see what we have left over. 90 minus 57 in the calculator leaves me with 33 degrees for this top angle. If I still am trying to solve for this diagonal, I'm still going to call this x. But now let's take a look at which trig function I would use. My opposite is missing. I have nothing there, and I'm not asked to solve for it. My adjacent is the 84, and my hypotenuse is the x value I'm trying to get. So A and H are the two letters I would use with my trig function. A and H is cosine. So I could do this cosine of 33 equals the adjacent of 84 over your hypotenuse of x. Again, if you switch the two because your variable is in the denominator, we would do x equals 84 over cosine of 33, and we should get the same answer. And let's check. 84 divided by 33 cos equals, and again, 100.16 is what we get in our calculator. So notice I did two different ways of finding the diagonal. It just depended on which triangle I wanted to use. I could use either this triangle here, or I could use this triangle here. But if I use the second triangle, the one that's up top, I have to first solve for this angle by subtracting 57 from 90. Okay, so we did two different ways for this one, which is great. As long as you recognize it's trig, I think you would have done fine. Let's keep moving on. Last question on this page, 157. Find the value of x to the nearest tenth. Okay, now this looks like a really complex diagram. There's even some shading going on. There's some parallel lines, but let's go ahead and let's just zone in on where we have some information. Okay, now looking at this, you should notice there are two triangles that are overlapping here. We have one triangle here at the top where we have a left side length of 21 and a right side length of 77. And then we have a triangle behind it overlapping it. It's a little bit bigger. And now we have the entire left side and the entire right side. And it's broken up into two parts. We have no way of knowing if these 2 points here are midpoints. That is not at all what we are told. We have no congruent symbols here. They don't tell us anything like that. So don't assume that 77 is equal to 11x plus 1. Absolutely not. Let's think what else we do know, though. Well, I know that these two lines, in fact, we have several lines going down, but these two are parallel. If those two lines are parallel, that means we have this angle and this angle that are congruent because they're corresponding angles. Same thing on the right. These two angles are going to be congruent because they're corresponding. So since the two are triangles and we have two pairs of angles congruent, the two triangles are similar because of a similarity. So the red triangle, the little one at the top, and the slightly bigger blue triangle are similar. What we could use are proportions when things are similar in order to solve for a missing side length or an x value. Now what we can do is we can do the 21 on the left over the entire side length if we want to, but we're going to use something called the side splitter theorem, which says that you can match up the pieces that make up the sides. So for example, I'm going to match up 21 with 77, the two top pieces, left and right. So 21 matches up with 77. In the same way that 30, which is the bottom piece, matches up with 11x plus 1. Here's a proportion, and we're going to solve. So for this question, it's very important that you recognize that those parallel lines are showing you that there are corresponding angles that are congruent, so our triangles are similar because of the a similarity postulate. Let's go ahead and solve, because the solving is also pretty important here. When we go ahead and solve, we cross multiply. The key is that you make sure you keep your 11x plus 1 in parentheses, because you want to multiply 21 by both terms. So it's going to be 21 times 11x plus 1 equals, and now on the other side, we're going to have 77 times 30. Let's go ahead and do that in our calculator. 77 times 30 equals. So it's 2,000. Ooh, change that. 2,310. Now, we can distribute the 21 to both terms. That's one option. I don't like doing that. I think that's more work. So what I'm going to do is a quick trick. I'm going to divide both sides by 21 so I can free up the parentheses. So I'm going to go ahead and cross those out. So now I'm going to get 11x plus 1 equals, and now in the calculator I'm going to do 2310 divided by 21 equals, so I get 110. Now subtract 1 from both sides, and we get 11x equals 109, and then we're going to divide 109 by 11. So 109 divided by 11. So that's a repeating decimal. let's go ahead and write down that our x value, let's see if they ask us to round, to the nearest tenth. Okay, so we're going to round to the nearest tenth. X equals 9.9 units. Okay, so just to recap this question for a moment. Most of this shape was unimportant. In fact, all of this here was unimportant. Like, none of this mattered. Why did we even shade something in? It doesn't even matter. What's important here is that we had two triangles that were similar, so we had to use proportions. And the way that we knew they were similar were these parallel symbols that let us find corresponding angles. Okay, we are done with this page. Only a few more.